Rüdiger completed his studies of chemical engineering and safety engineering at the University of Dortmund in Germany as a diploma engineer. He has been involved in the development, fire testing, approval, and marketing of high-pressure water mist systems for over 25 years, I think. And Rüdiger is also a founding member of IWMA. Thank you very much. Fire away, please.
Yeah. Thank you, Bettina, for the introduction. Good morning to everyone. My presentation will focus on the standards and approval behind this technology, the water mist, which is slightly different to other technologies on the market. So as Bettina introduced into her presentation, water mist has been around quite a while now, almost 25-30 years. And it started its development in the marine field, protection of machinery spaces on ships, but also then spreading to the accommodation areas. And this is where the first internationally published standards have come to the market by the IMO, the International Maritime Organization. For accommodation areas, that's the IMO 800, which has been revised into the MSC 265. And for the machinery space application, currently it's the IMO MSC 1165, which are referred to when water mist is used on board of ships. But application have been seen very soon also for land applications. And this is where a number of standards have come to the market. The first one which were published are the American NFPA 750 in conjunction with the FM approval standard, the FM 5560, being published by FM approvals. But very soon also in Europe, a working group has started to work on land-based standardization by the CEN working group. And this is where the PREN 4972 is internationally referenced standard when it comes to land-based applications. Apart from the ones you've seen on the previous slide, other standards have come up, particularly in Germany. The German VDS has published a standard on water mist technology, the VDS 3188, and they just recently published fire test protocol standards and approval standard, which is called VDS 3883, where similar to the American, the FM 5560, all the different fire test protocols have been published. In the US, UL have also looked into water mist technology. They mainly focused on the components, on the nozzle as a particular component. So the UL 2167 standards focus on testing and certification of nozzles, which are then used in various other standards for marine and land-based application. And in the UK, the British Norming Institute, the British Standard, have published two standards, one for industrial and commercial water mist systems and one for residential, which are also providing fire test protocols to certify, to test, to approve systems too. And the French have looked into this as well as the Nordic countries. So you can see there's a number of standards available today to refer to when it comes to this technology. However, all these standards have in common that they have a different approach than conventional standards for conventional systems. So those, you know, for sprinkler systems or for gas extinguishing system, the standard have been built around on experience that is available from the market, from real fires that the system have performed successfully on. They mainly refer to genuine layout parameters, which you find in the specific standards for this technology, which are either based on a floor area which is protected, so defined by a spacing between nozzles, or by volumes, by a concentration that you generate when it comes to gas extinguishing systems. Now, these type of technologies very seldomly come up with specific fire tests to analyze and to demonstrate the performance of the system for individual type of risks. This is completely different with water mist technology. With water mist technology, all standards which you have seen on the previous slide do not provide genuine layout parameters for the systems. For water mist technology, every supplier of the technology, every manufacturer has to perform full-scale fire tests per individual application to demonstrate the performance of the individual systems on the fires, and to generate the specific design and layout parameters for the individual system. This is a common approach, which also will remain to be the same for the future, since there are many different technologies which have come to the market. Bettina was mentioning that there are low pressure systems, there are high pressure systems, but also there are different ways to generate the water mist. And they cannot be designed according to a general layout parameter. So this is where these fire tests are key to demonstrate the performance and to generate the layout parameters. But this is also where water mist technology is the only technology where every design that is provided to the market is 100% fire tested. So you have demonstrate that the system is effective on the fire. Now, the certification approach for the systems do include these fire tests, which I was just mentioning, and the fire test protocols can be found in the various standards, which you will see in the following slides. These fire tests, of course, have to be conducted and performed by an accredited laboratory into the standard, the ISO 17025 standard. A norm is referenced when it comes to the kind of approval and certification the laboratory should have. And this is the same kind of standard that also the laboratory shall have, which then after the fire test inspect the components that have been used in the test. So of course, component tests also have to be carried out, like for any firefighting system, to demonstrate that the equipment, that the component are robust enough for this type of environment they are intended for. And this is where a number of different component tests are described in standards I will show on the following slides. And after successful performance of the fire test and of the component test, the manufacturer, the supplier of the system, has to produce a manual, which is like a design manual for the system, which is called DIOM manual. And DIOM stands for design, but it also includes installation, operation, and maintenance of the system for the specific system that is provided to the market, to make sure that the system is properly installed and also maintained. Now, for ordinary hazard type of risk, that means building protection, there are a number of standards on the market which provide fire test protocols, which describe how to conduct the fire test. In these fire test protocols, the type of fire load are described, the arrangement of the fire load, but you will also find acceptance criteria into those. What are the pass-fail criteria for systems? And I don't want to read out all the individual standard, which you see on the left side, but you see that very different scenarios are tested. So you have arrangement of sofas with mattresses, like you would find them in public spaces, into entrance area of buildings, but also into hotel rooms, maybe into hospital areas. And then you have scenarios for offices, like on the top right one, and also for storage areas, different kind of storage, whether it's a block storage or a shelf storage, and all these different type of risk and arrangement of the risk have to be tested and successfully passed with the system. And once this has been done and the component test has been conducted, there is the final certification process, which also includes the production of the DIOM manual. And then there's a final certification document, which is provided by different authority. Here you see one by VDS and another one by FM approval, but there are also other bodies issuing this kind of certificates. And today, a number of applications in the ordinary hazard field, so in building protection, are available with respective approvals. This covers almost everything you will find in office spaces, public spaces, in hospital, care homes, hotels, heritage buildings, but also libraries, archives, museums. It also includes technical areas into such buildings, and data centers for sure is a key application also for the technology. It also includes apartments, and this is where more and more systems are equipped in specifically Scandinavian countries. When it comes to industrial type of risks, the fire loads are completely different. Instead of solid fire loads, so class A fire loads, you will find more flammable liquid fire loads into this field. So applications like transformers, machinery spaces, generators, turbines, industrial deep fat fryers, but also storage areas and production areas for flammable liquids are protected with these systems and are thoroughly tested in all these fire tests which the system have to undergo to get system approvals. Cable tunnels, the top center one you see, is one another very important application field where water mist has been used in the last 20 years. And again, the specific standards on the left side provide the protocols which describe how to perform the test to get the system certification and approval. And again, as a final process, after the component test has been successfully carried out, a DIOM manual has to be produced, and a respective approval is issued by certification bodies, again here like VDS and FM. And a number of different type of risks are having such approvals today, all different kind of machinery spaces, including turbines, generators, but also transformer areas have approvals, paint booth areas, industrial deep fat fryers are part of approval processes, and cable tunnels, as I mentioned initially. The component tests are mainly looking in the key component of the system, which is the nozzle. It shall be ensured that the water mist is generated at the right density, at the right quality at any time when it's needed. And this is where a number of fire test protocols are available within the standards that you find here on the slide. They are having different tests for automatic nozzle, glass bulb operated nozzle, as for open nozzle. But once all these tests have been successfully performed, a system approval is given for the component. But the nozzle is not the only component tested, also valves, pump units, cylinder systems, they all undergo a verification process to make sure that the system availability and quality is high, and make sure that the system is available anytime it's needed. The DIOM manual, which I was mentioning, shall contain certain elements. You find on this slide an extract from the European standard, the PRN 4972, which describes what kind of specification has to be given in the manual. And of course, the type of nozzle that shall be used for the individual kind of risk shall be given, but also the installation parameters, meaning maximum installation height, maximum and minimum distance between nozzles, the flow rates of the individual nozzle, the minimum pressure that shall be available at the nozzle. All these details have to be provided, but also details on the ambient, what are the ventilation conditions the system works with, what are maybe restrictions that have to be taken into account, and maybe some additives that have to be used with the system. All of this has to be specified by the system supplier. And this kind of approach with the DIOM manual makes sure that the system are properly designed by designers of the system, but they're also properly installed by the installation companies, and they are properly maintained. Maintenance is also key to the technology, like for any fire protection system, to make sure that the system is available at any time. And of course, the operators of the system have to be thoroughly instructed on how to handle the equipment. And this is where the operational part is also a key part in the DIOM manual. And this altogether ensures the highest reliability and safety of the system. Thank you very much.